Good morning, students. Today we will discuss about the concept as photoelectric effect. Before going to know what is the meaning of photoelectric effect, we should know about the definition. What is the meaning of photoelectric effect and some experimental arrangement of photoelectric effect that we can discuss today. Here, first of all, the photo means this is light. The photo means this one is light. By using the light energy, we are going to emit the electron from the surface of the metal. That phenomena is called as photoelectric effect. That's why the title becomes photoelectric effect. The photo means light energy. The photo means that is light energy. By using light energy, we are going to emit the electron from the surface of the metal. Whenever that emitted electron is moving from cathode plate to anode plate, there is a generation of current in the cycle. That generated current is due to use of the external energy as light energy. Means by using light energy, we are going to produce a current. How we have to produce current here? By using light energy, we are going to emit the electron from the surface of the metal. That emitted electron is moving from one point to another point. Whenever the electron is moving from one point to another point, there is a generation of current. That generated current is called as photo current. That's what the title here, the photoelectric effect. Here, what is the definition of photoelectric effect? It is the process. The definition, it is the phenomena. The definition, it is the phenomenon. Phenomena means this is the process. Frequency of radiation. Radiation called photoelectric effect. Called photoelectric effect. What is the definition of photoelectric effect here? It is the process. Phenomenon, it is the process of emission of electrons from the surface of the metal by using which energy? Frequency of incident radiation. By using light of suitable frequency of radiation. Suitable frequency of radiation. This process of emission of electrons from the surface of the metal is called as photoelectric effect here. Please remember this one. Photo means this is light energy. By using light energy, we are going to produce a current. Then in order to produce a current, we should know first what we'll do. First, we'll emit the electron from the surface of the metal. Whenever the electron is emitted from the surface of the metal, those emitted electrons are moving from one point to another point in the circuit. Whenever the electrons are moving, there is a generation of the current. In order to generate the current, what we require here, that is the external energy. That external energy is photo energy, means light energy. That's why the definition of this photoelectric effect, it is the process of, or it is the phenomenon of emission of the electron from the surface of the metal by using suitable frequency of radiation. What is the meaning of suitable frequency here? Whenever in order to emit the electron from the surface of the metal, we should require a certain frequency of incident radiation. Let us consider here one metal is there. This is a metal. Generally, I am taking this is a metal. Our intention is to emit the electron from the surface of the metal. Then, what we do here, I am using a light of suitable frequency. For example, I am taking ultraviolet radiations. I am not taking the red light or violet. Instead of these radiations, I am using here ultraviolet radiations. What is the reason here? The ultraviolet radiation having a certain frequency. The frequency that is somewhat more than red and violet. If you use red light as well as a violet instead of using ultraviolet, in case if you use red and violet, there is no emission of electron from the surface of the metal, because these two lights having low frequency. The frequency is very lowest for these two compared to ultraviolet radiations. In this case, there is no emission of electron from the surface of the metal. That's why in order to emit the electron from the surface of the metal, we should require the radiation which is having a suitable frequency. Getting, for example, I am using generally one radiation here. I am not taking out UV radiation. This is somewhat I am using red light. This red light having a photon. This red photon is whenever this red light is incident on the metal surface, the photon energy is getting transferred to the electron of the metal. Then this energy given by the photon or this energy given by the red light is not sufficient to this electron to come out from the surface of the metal because its frequency is lowest. This frequency is not sufficient in order to emit the electron from the surface of the metal. Then I am using another light. For example, I am using UV light. It is having more frequency compared to red as well as other radiations. That's why whenever I am using UV light instead of these radiations, it is having more frequency. Whenever ultraviolet radiation is incident on the metal surface, its energy is getting transferred to the electron of the metal. Then by receiving that energy from the UV radiation, this electron is easily coming out of the metal. That's why we are mentioned here by using suitable frequency of incident radiation. Incident means it is falling on the metal surface. Then that's why the definition of the photoelectric effect is it is the phenomenon of emission of electron from the surface of the metal by using which energy? Light energy. But the condition is there that light it should have a suitable frequency, a certain frequency. If it is having a lowest frequency, then you are not getting a photoelectric effect. Photoelectric effect in the sense it is the phenomenon of emission of the electron from the surface of the metal. In order to emit the electron, we should require a light energy. That light energy should have a minimum cutoff frequency or certain frequency. If it is having lowest frequency, if the light is having lowest frequency, then there is no photoelectric effect, means there is no emission of the electron from the surface of the metal. That's why this light should have a minimum certain value, certain fixed value or certain value or more than that. That's why this light must and should it have a certain frequency in order to produce a photoelectric effect. And next one, there is a schematic diagram of the experimental arrangement of photoelectric effect is there. That one, the schematic arrangement of photoelectric effect. How to produce a photoelectric effect? There is an experimental procedure is there. Experimental procedure is there, that is schematic diagram. This is the diagram showing the experimental arrangement of photoelectric effect. How to produce this one? Let us consider this is the diagram already here. This one is evacuated glass tube is there. This is all wire arrangement, and this one is the battery. This is the battery, and this is the voltmeter. The voltmeter means this is an electrical instrument in order to measure the electric potential difference at this point and at this point. For example, let us consider it is a A point and this is a B point. At the A point, the electron having somewhat electric potential energy and the electron having the electric potential energy at also this point. What is the difference in the electric potential at this point and this point? That can be measured by using electric instrument is called as voltmeter. What is voltmeter? It is an electric instrument. It is used to measure the electric potential difference between 2 points. For example, the electric potential at the cathode plate and the electric potential at the anode plate. And what is the electric potential difference between these 2 points can be measured by using one of the instrument is called as voltmeter. And next one, here mu A is there. This is micrometer. Micro means this is as a no variable. Micro means the range is 10 to the power of minus 6. Getting, because this current is here, what we are going to produce a current, that current is very lowest current. That's why in order to measure that current, we are going to use one of the instrument is called as microammeter. The micro means that is the 10 to the power of minus 6. This is very negligible current. That's why we are going to measure that current. We are going to use the instrument as a micrometer. What is micrometer? Or just you can call it as a emitter. Generally, instead of calling micrometer, you can call it as a emitter. The emitter is an instrument. We are going to use it for measurement of the current. How much current is flowing in the circuit? Getting how much current is flowing in the circuit? That flowing current can be measured by using one of the instrument is called as emitter. And next one is, this is a commutator. 1, 2, 3, 4. Here a multi-key plug system. The commutator means this is a switch system. Here multi-switch system is there. That multi-switch system can be calling it as commutator. And next one is the rheostat. The rheostat, it is an electrical instrument. It can control the current in the circuit. To control the current in the circuit as well as to control the voltage of the circuit or voltage of the battery. To control the voltage, or else generally we can call it as, in order to control the current in the circuit, we are going to use the one of the electrical instrument that is called as rheostat. This one is the rheostat, this part. And next one, this is a battery. Because this is a battery, as you know very well, it is an electrical instrument. In order to use it for the supply of the current, getting this is battery, and this is in order to control the current. We are going to use, this is a rheostat. This part is a rheostat. In order to measure the potential difference between these 2 points, this is a cathode and this is the anode plate. Here potential is there, electric potential that the electron has, and here also whenever the electron coming at this point, it is having the electric potential. And what is the difference in the electric potential that the electron has, that can be measured by using voltmeter. To measure the current, we are going to use, this is microammeter, multi-key plug system is there, this is commutator, this is a circuit, this is all wire system, we are connected here. And this plate is called as, this is cathode plate. The cathode plate are also we are going to call it as emitter plate. Why we are going to call it as emitter plate? Because whenever the light is falling on this plate, there is a ejection of electron from this plate. That's why this plate, we are going to emit the electron from this plate. That's why we are going to call it as emitter plate, or also called as cathode plate. And whatever it is the electrons, or whatever it is the number of the electrons, they are going to emit from the emitter plate. They are moving towards the anode plate. This plate is called as anode plate, also called as collector plate. Why it is called as collector plate? This is anode plate. Its another name is collector plate. Why it is called as collector plate? Whatever it is the number of the electrons they are emitted from the emitter plate, those electrons is collected by this plate. That's why this is also called as collector plate. And this one is quartz window. We should not close completely this window because our intention is to enter the light inside the tube. This is completely black. There is no entering of the radiation inside the tube. If the radiation is not entering into the tube, means there is no emission of the electron from the surface of the emitter plate. That's why this is a light source. For example, you can call it as a sun. Getting UV radiations, it is having high frequency. You can get the UV radiations from the sun also. Here, this is the glass system is there. We are calling it as a quartz window. Here, through the glass, the light is entering into the evacuated glass tube. This is totally evacuated glass tube. Why it is called as evacuated glass tube? Evacuated glass tube means this is a glass tube which is free from the air particles. There is no air particle, there is no presence of any air particles inside the glass tube. This is completely vacuum is there. Because in order to move the electron from one point to another point, then this place should be completely vacuum. Or else if here air particles is there means this electron interact with the air particles and become neutralized. That's why in order to unneutralize the electrons, this place should be completely vacuumed. That's why this tube is called as evacuated glass tube. Evacuated means this is free from air particles. There is no any presence of air particles inside the glass tube, and this is experimental arrangement. The schematic diagram, or else you can call it as the experimental arrangement of this is photoelectric effect here. This is emitter plate. This plate is also called as a photosensitive material. Because why it is called as a photosensitive? Photo means light. This is sensitive to light energy. How come sensitive to light energy? Whenever the light is incident means whenever the light is falling on the plate, suddenly there is a ejection of electron from the surface of the metal. This is a metal surface. That's why we are calling it as an emitter plate. Those emitted electrons, they are moving towards the anode plate. There is a reason why the electrons are moving from cathode to anode. The reason is that, as you know very well, because the charge of the electron is negative, and here this multi-key system I am used here. This is the battery. This is supplying energy. This is supplying energy to the circuit here. Let us consider this circuit. This is the T system. This wire is connected to which plate? Emitter plate. Getting this wire, if I am connected this wire to here this system, then this is going directly to the battery positive. This is going directly to the battery positive. Then the potential of this plate becomes positive. Then if I connected this point to here, then this is goes to battery what, and this is goes to battery negative. This is goes to battery negative. Then this wire is connected to which plate? Anode plate. Then the potential of anode plate becomes negative. Or else, in order to change the potential of anode plate as well as a cathode plate, what we can do here? Just we can change the switches here. The connection you can change. If you connected this wire to this one and this wire to this one, then this plate becomes, this wire is directly connected to cathode plate, then this wire is goes here and it is directly connected to, that is battery negative. Then what is the potential of this plate? The potential of this plate becomes negative potential. And here I am connected this switch to here, and this one is connected to battery positive. Then the battery positive means the potential of anode plate becomes positive. In order to change the potential of anode plate as well as a cathode plate, we are going to use the multi-key system here. Here, in order to produce a photoelectric effect, I am changing this the circuit here. I am connecting this switch to positive and this switch to negative. Means the potential of cathode plate becomes, it is connected to which terminal of the battery? This is positive terminal, and this one connected to this anode plate connected to negative terminal of the battery. Means the potential of this plate becomes negative. Means this plate becomes positive potential and this plate becomes negative potential. I am using here light source. What is the light source? We are going to take the light energy. I consider the sun as a light source. Whenever the light, for example, I am taking UV radiations because it is having somewhat more frequency, and this UV light is possible to produce a photoelectric effect from the surface of the metal. Whenever the UV light it is entering into the quartz window and falling on the emitter plate, whenever this light is incident on the emitter plate, suddenly the energy of the photon is getting transferred to the electron of the metal. Whenever the electrons of this metal receive the energy from the light, those electrons are coming out of the metal, and those electrons has to accelerate from emitter plate towards the collector plate. How to do that one? That's why in order to move the emitted electron from emitter plate to anode plate, I made it here. The potential of this plate is positive. How to make that one here? Just you can changes the switch here and made this potential as a positive and made this potential as a negative. And the potential of this plate is positive and emitted electron, its charge is negative. As you know very well, whenever the plate potential becomes positive and charge of the electron is negative, then what is the direction of this electron? This electron is moving in this direction because this positive potential attracts the negative electron. But our intention is to what? We are not attracting the electron here. Our intention is to send the electron from this point to, that is towards the anode plate. Then what we can do here? Again we can changes the switch here. Again you connect this one. Connect this wire to here and this wire to here. Then the potential of this plate becomes negative and potential of anode plate becomes positive. Depending upon this arrangement by using commutator, whenever the light is incident on the metal plate, suddenly there is an ejection of electron from the surface of the cathode or from the surface of the metal. Whenever the electron is ejecting from the surface of the cathode plate, then the potential of this plate is negative and the charge of the electron is negative. And negative potential is not attracting the negative particle. Then instead of attraction, there is a repulsion in between this negative potential as well as this negative particle. The electron has experienced the electrostatic force of repulsion from this plate. That's why this electron experiences the electrostatic force of repulsion from the negative potential, and of course it is moving from emitter plate and towards what? That is collector plate. And the potential of this plate becomes positive. The potential of this plate becomes positive means it is not repelling the electron. This plate attracting the electron and this plate repelling the electron means one side, at this side electron experience of electrostatic force of repulsion, and this side these electrons experience the electrostatic force of attraction. As a result, the emitted electrons are moving from which plate to which plate? That is, the emitted electrons are moving from cathode plate to anode plate. Whenever the electrons are moving from one point to another point, suddenly there is a generation of the current. Getting, as you know very well generally, what do you mean by current? The current is called as, how to define current? The flow of electrons. The flow of electrons in the conductor or flow of electrons in the wire, metal wire, that is called as current here. Here the electrons are moving from one point to another point. It means that whenever the electrons are moving from one point to another point, suddenly there is a generation of the current. That generated current we are going to call it as photocurrent. Photocurrent. That generated current, simply we are not calling it as a current. Instead of calling it as a current, we are going to call it as photocurrent. What is the reason why we are going to call it as a photocurrent? Because what is the reason behind the generation of the current? That is a light. Light means photo. Because in order to produce the current, which is the reason behind this one? Light energy. The light energy means that is the photo means light energy. By using light energy, we are going to generate a current. That's why that generated current is called as photocurrent. Getting? Whenever the light is simply this one, the light enters the tube, falling on the emitter plate, which is photosensitive. Whenever the light is incident, suddenly there is ejection of electron from the metal, and then this potential is positive because here connection is there. Potential is negative, plate potential is negative, charge of the electron is negative. Suddenly electron is emitted from the metal. That emitted electron experience the electrostatic force of repulsion from the metal, and it is moving towards the anode plate, and the potential of the anode plate is positive. That's why the anode plate attracts the electron. One side there is an electrostatic force of repulsion is there, another side there is an electrostatic force of attraction is there. That's why at the both sides the electron experiences the electrostatic force of repulsion, here the electrostatic force of Attraction, as a result, the electron is moving from cathode to anode. Generated current is moving in the wire. Whenever the electrons they are moving in the circuit, suddenly there is a generation of current. That generated current in the circuit is called as photo current. Ready? This current is called as photo current. And next, here some terms are there. Here some terms associated with this photoelectric effect. Those terms, here some terms are there related to this photoelectric effect. Just you can remember this experimental arrangement. Arc is working. The electrons are ejected. They are moving. Suddenly there is a generation of the current that is moving in the circuit. That current is called as photo current. This is all experimental arrangement of photoelectric effect. Get it? Here some terms are there. Those terms are related to photoelectric effect. In order to study the photoelectric effect, getting there some terms are associated with photoelectric effect. Those terms are the first one, threshold frequency. The first one is the threshold frequency. Second one, stopping potential, are also called as retarding potential, are also called as this is negative potential. Negative potential, and third one is the saturation current. These are important three terms are there. In order to study the photoelectric effect, these terms are associated with this concept. These terms we can study in the next class.